Hello students and welcome to our today's class. Today I want us to discuss about variation. Variation, it is actually the change that is witnessed on a particular quantity as a result of change in another quantity that they are related. And in this particular case, we are going to borrow a lot from what we discussed on proportion. Proportion, we said actually, we have got two categories. We have got direct proportion and inverse proportion. For direct proportion, we said it occurs when a particular quantity increases as a result of increase in another quantity. And we gave an example there of the number of cups and the cost that is going to be associated on the number of cups. Example, if the cost of one cup is 20 shillings, meaning that if I buy one cup, I'm going to incur a cost of 20 shillings. If I buy two, I'm going to incur 40 shillings. If I buy three, I'm going to incur 60 shillings. So you'll be able to see here, as the number of cups increases, the cost also increases. That is a very good example of direct kind of proportion. Then we have the other one, which is the inverse. The inverse occurs where if you increase one quantity, the other one decreases. Or if you decrease one, the other one increases. The two quantities are not moving in the same direction. And the example that we gave is of an amount of money that was to be shared among students. That amount of money was actually 120 shillings. If, for example, that 120 shilling was to be given to students and the students, maybe it is only one, that one student will be given the whole amount, which is 120. If they are two, they will share 120, meaning that one will get 60. The other one, if they are actually three, each will get 40. So as the number of students increase, the number or the amount of money each will get goes on decreasing. That is an inverse kind of a scenario. So the same case here, we are going to bring that one into variation, whereby we are going to have the direct variation and the inverse variation. Direct variation will occur where increase in one results into increase in the other. Decrease in one results into decrease in the other. When we talk about inverse variation, then it simply means that we increase one quantity, the other one decreases. For inverse, we can have something like this. Maybe we have got time here and maybe the speed and time the journey is going to take, you will realize that maybe if the person or the driver drives at 120 kilometers per hour, it means that that particular person is going to take 1 hour to arrive the destination if that particular distance is actually 120 kilometers. So if I travel for 120 kilometers and the distance is 120 kilometers, I only take 1 hour to arrive to my destination. If, for example, I travel at 60 kilometers per hour, the same distance of 120, then I'm going to take 2 hours. If I travel at 30 kilometers per hour, the same distance of 120 kilometers per hour, I'm going actually to take uh, 3 hours. You realize that I'm going actually to take the 4 hours here. So you realize that the more or the lesser the speed, the more the time it is going to take. The more the time is going to take. So decrease in this results into increase in the other. So that is a very, very good example of inverse variation. So in this particular area now, we are going to see the mathematical calculation of this kind of interrelationship. So we might ask ourselves, if this one is increased or reduced to this particular level, what would be the change in the other quantity? So let me start by saying that in variation is normally represented by this sign. So this sign, anywhere you see it, it simply means varies. So it can be x varies. So If we start with the direct, we can say that x varies directly as y. X varies directly as y. So anytime we are given a variation or we come up with a variation expression, we can go ahead and change this to be an equals. Instead of having varies, we say x is equals. But in doing so, we need to insert a constant on the right hand side. So we can put it like this: x is equals to k y. So instead of putting varies, we put is equals, but we must include or insert a constant here. This constant is normally referred as the constant of proportionality. The constant that we are inserting on the right hand side so that we can replace the variation with equal sign is known as the constant of proportionality. So having done that, now it is workable. We can be able to work out that particular equation. Let us see if, for example, you are told that x varies directly as y when x is equals to maybe 6, y is 2. And now you are told find x when y is equals to 5. That is what you are told. So once you have been told this, that x varies directly as y, we can come here and you say that x varies directly as y. We put it like that. Then we said it is not easy for us, or actually it's not possible for us to work it in this way. We can now say that x is equals to ky. Therefore, there is that point where you are going to be given the two values of both x and y, where you are given both values of x and y, or the unknowns that you are working with. So at this point, you are told that when x is 6, y is this. So we have been given both the values of x and y. So we can come here, where we have x, we put 6, and where we have y, we put 2. So we can come here and say that 6 is equals to k, we don't know, times y, which is the same as actually 2k, like that. So we can say that 6 over 2 is equals to k, therefore k is equals to 3. After finding the value of k, which is your constant, you can come to your equation here and you will substitute k with 3 so that you have got x is equals to 3y. Because k has been calculated, you can replace it with 3 because that is actually the value. Therefore, this is actually referred as the equation. This is the equation connecting x and y. So you replace it here, you use the portion of the question where you are given the two values of the unknowns that you are working so that you can be able to determine the constant value. Once you have the constant value, come here and replace it here so that you can find the equation connecting the two values. After now doing that, now we can be able to calculate what will be x when y is 5. When y is 5, you can use the equation to calculate that. So x would be equal to 3 times 5, because here we are told it's 3y and y here is 5. So x will be equal to 15. X will be given by 15. Let us look at another case whereby we are told this, that the length which is L centimeter varies directly as temperature. Varies directly as temperature, which you are told it's 3 degrees centigrade, like that. When R is equals to 5, temperature is equals to 65. Find R when T is equals to 69. That is what you have been told. So it is easy. Come here and say that L varies directly as T. So R is equals to KT. That is the starting point. Go to the point where you are being given the two values. Now, in this case, you have been given the value of R and T. Here is the case. When R is 5, T is 65. So you can come here and you say 5 is equals to 65K. Just substitute here. So 5 over 65 is equals to K. That is the starting point. Therefore, now you can come up with the equation. Come up with the equation which says that R is equals to, we don't know T, but K has been calculated, which is 5 over 65T. Now you come and say, what will be the value of R when T is 69? Therefore, R would be equal to 5 over 65 times 69. You work out this and you get the answer for that particular question. So that is a very, very good example of direct variation and how we work it. So in any case, whether you are asked or not, you need first of all to determine the equation. And how do we determine the equation? Get the value of K and insert it here. Then you have the equation that you need. This equation is what will help you to find the value that you have been asked in the question. Lastly, on direct variation, you can be given something like a table. You are given a table like this, where now you are told we have got two unknowns. The unknowns is E and M. You are told this when E is 2, this is 1.2. When this one is not known, this is 1.8. And when this one is 5, this one is not known. Now you are asked to fill the blank spaces. That is this point, and actually this point. So you need to note that there is a point where we have been given the value of E and M. Where we have been given the two values, that is now enough for us to give the equation. So we need to come here and say E varies directly as M. Those are the two unknowns. Therefore, E is equals to Km. You come here where we have both E and M so that we can find the value of K. So E, which is 2, will be equal to 1.2 M. So 2 over 1.2 will be the value of M. The equation here now will be equal to E is equals to 2 over 1.2 M. Now you can be able to get the values that are missing. Use this particular equation to find them. So in the first case, we are asking, or we are trying to get the value of E. So E will be equal to, at that point, M is 1.8. It's going to be 2 over 1.2 times 1.8. And the other case, we are determining the value of M when E is 5. Therefore, you come just here where we have E, because it is known as 5, will be equal to 2 over 1.2 M. Therefore, 5 times 1.2 over 2 will give us M. I've just multiplied by the reciprocal of this so that I can remain with M on this side. And that is actually going to be the answer. Having said that, allow me also to discuss about the inverse variation. Inverse variation. The procedure for direct and inverse variation is the same apart from one point. Whereas we normally say that x varies directly as y, for inverse, this is for direct. For inverse, we are going to say x varies inversely. We put 1 over y. This is now for the inverse. That is actually the only difference. The only difference between direct, for direct we don't put 1 over, but for the inverse we must put 1 over the other unknown. So in this case, if we multiply by the constant k here, you will find that x will be equal to k times 1 is k over y. That is actually the only difference between the two kind of variations. So we can have this. You are told that P varies inversely as Q. P varies inversely as Q. Then you are told P is equals to 30 when Q is equals to 2. Find P when Q is equals to a third. So one thing you need to come, the moment we are told it is inversely, then P varies inversely as Q. Therefore, P will be equal to K over Q. Now you come here where we have been given the value of P and Q. So P is 30 is equals to K, we don't know, but Q is known to be 2. So if we multiply by 2, you'll find that 30 times 2 is equals to K. So K actually is equals to 60. So come here and you put K in this particular equation. Where we have equal, don't put where we don't have equal sign. Put here where we have equal and the value of K is known. Therefore, the equation connecting P and Q would be equal to P is equals to 60 over Q. 60 over Q. Now we are told that when Q is equals to a third, what will be P? So P will be 60 divided by, remember here it is divided by a third. So it's going to be 60 times 3 over 1, which is going to be actually 180. So basically that is how you work it out when it comes to inverse variation. Maybe we can do one last and then you can go to the notes or material that I've shared on the platform that is on the dashboard, and you try the remaining questions. Then we have been given this that y varies inversely as x. When y is equals to 6, x is equals to 44. Find the equation. Part A is asking, find the equation connecting y and x. B, you also determine y when x is equals to 2. As I said, the moment we find the word inversely here, we put y is equals to 1 over x. Actually varies inversely as x. You put 1 over x. So y is equals to k over x. Now you come to this point where you have been given the value of y and x. So y is 6. So 6 is going to be equal to k over 44. So multiply that value. So 6 times 44 will give us what? K. After getting the value of k here, you need to come and replace it here so that you can get the equation. After getting that equation, you substitute the value of y so that you can get the value of x for you to be able to determine that particular answer. That is actually what I wanted to discuss today, and I hope you are able to internalize and also understand those concepts. Thank you very much. Finish the work that I've given you. Go to the dashboard. On this particular topic, we have a number of questions which have not been solved. Try solving them using the approach that I've given you. Thank you very much.